All right, so let's get started. All right, and y'all don't be afraid to interrupt me or ask any sort of questions or like correct me or anything like that. So it's pretty informal. So all right, so this is basically an introduction to ROS. Um, so the slide changed, right? You can see the what is ROS slide now.
Yeah,
All
we
right,
can see it.
all right, cool. So basically, what is ROS? So it's a middleware that does the following stuff, right? So it can interface with hardware, it can manage packages, and it can pass messages between different processes. Um, and a middleware is basically it's something that is kind of like I've heard it referred to as like a software glue or something. So it's a way that you can like communicate between different softwares and have them like work together. Um, and when it says package management, a package is basically just like a collection of code that does one thing. And ROS is important because we use it to program all of the robots that we have and all of the simulations that we use for all of the virtual competitions as well. And one of the most important concepts in ROS is the concept of publishers and subscribers. So essentially in ROS, data streams are passed between different processes, and these processes are referred to as nodes. So as you can see in this little diagram at the bottom, here's like a simple architecture that you could build in ROS, right? So you could have two nodes, and these two nodes are usually in the form of Python scripts, or they could also be like C++ files as well. Um, so in this example, we have one node that's going to publish out a message to something called a topic, right? And we're going to get and the other node, node number two, it subscribes to this topic and it receives the messages from node number one. And the thing about publishers and subscribers is you want to use these when you want to continuously send and receive information. So like you would specify like a certain rate. So for example, you would specify like, okay, node number one, I'm going to publish like 10 messages a second, and node number two is going to receive those 10 messages every second. And the messages that you send, there's like different predefined message types. So you can have a string, which is essentially just like a sequence of characters, um, a, a pose, which is essentially a position and an orientation, vector 3, which is essentially like a x, y, z coordinate, different things like that. So one thing I mentioned about the publishers and subscribers, right? Um, you generally use those if you want to continuously send information and receive information. But oftentimes there are times where you like only want to send something once or maybe like every periodically, not like all the time at a certain rate. So when you do this, you don't really want to use publishers and subscribers. You want to use something called services, right? Um, and services are defined like this. So you can see at the bottom here, a service is essentially consists of a request and a response. So kind of like how in the subscriber and publisher, we had like one node be a publisher and one be a subscriber. For services, we have one node called a client and one called a server, right? So what the client's going to do is it's going to request the server to do something, and the server is going to have a function inside of it called a callback. So whenever it receives a request from the client, it's going to execute some code in the callback function and send back a response. So again, just to summarize, like you're going to use services whenever you don't want like a continuous stream of data, but when you like only want to send things at certain times or maybe only one time. All right. So now that we went over these basic concepts, we're going to do like a little exercise to kind of see how this stuff works. Um, so in the exercise that I think would be good is to convert a color video to grayscale for 30 seconds, right? And like when we think of this problem, we can sort of decompose it into different things that we need to solve the problem. So one thing that we can do is we can sort of have a node, which is essentially a Python file that's going to take care of the logic of this little exercise, right? And the logic is essentially going to be a timer because what we want to do is essentially we want to start up a some sort of a node that's going to convert the video to grayscale, and we want to let it run for 30 seconds, and then we want to stop it. So that's our logic right there. And then another node would be used for the grayscale conversion, where it actually subscribes to the video. It does the conversion to grayscale, and it publishes back out the gray video or the gray images. And the third thing we need is a launch file. So like after we create these two nodes, right? After we create these two Python files that takes care of like all of these things that we need, how do we actually like run these? And the way that we run these is using something called a launch file. And when we execute the launch file in ROS, it'll start up both of these nodes. And we kind of have it in text here. And this slide kind of shows how it looks visualized. So we have the first node here, which is sort of the logic node that takes care of the timer logic. We have the second node here that takes care of converting the images to grayscale from the video and publishing back out to another topic. And just a reminder, a topic is something that you publish messages to and you subscribe to get messages. So how essentially it's going to work is this node is going to start the perception, start the grayscale node, and it's going to let it run for 30 seconds, then stop it. All right. Do y'all have any questions about this so far?
Where does the video stream come from? Like, who publishes to that topic?
Okay. Good question. So the video stream, I just kind of so we're going to be using a library. I think it's on the next slide. The library is called Video Stream Opencv, and there's like a MP4 file that, and this library essentially it has a node that will publish out the video stream to a topic. So that's I'm just doing that for like the tutorial's sake. But if you were to think about this in, let's say, one of our robots like the RoboSub or RoboBoat, then like you could imagine that we're gonna have like cameras on those robots, right? So those cameras are gonna be sort of where the video comes from, and that could be represented by this video stream topic here. But just for like tutorial purposes, I just installed this library here to just take a video that I downloaded and sort of publish it onto a topic. All right. Any other questions? Okay. Sweet. All right. So just to go over, is anybody would anyone like to like follow along and like code it like while I'm doing it? Um, so if anyone has like ROS installed already, then we can take a quick moment to like go through these things here. But if not, then we can go ahead and start the implementation of this example here.
I think implementation's probably good.
Okay.
Just
All
go
right. We
ahead.
can get started. right, so first let's start with this sort of perception manager node here. All right, let me open this up. Oop, wrong one. Okay, so I kind of made out, so this is the perception manager node, and as a reminder, we have like a to-do list here. So this node is essentially a Python class. So every node is going to be like a Python class, and this one we named it perception manager. And the first thing on the to-do list is to import all of the necessary libraries we're going to need, right? So the first library we're going to need is a library called ROS1. And generally, for every node that you make in ROS, you're going to want to import ROS1 just because it has a functionality for like time, like if you want to get like do some sort of timing, and also like logging stuff. So like doing some print statements and stuff like that. And the other thing we're going to need here is we're going to need to import a specific service. And the service that we're going to be importing here is called setBool. And the reason that we're going to be using this service here is because, just to review a little bit, the purpose of this node is to start this other node for 30 seconds, right? Keep it running for 30 seconds. So one way we can do that is we can essentially send the other node a Boolean variable, and a Boolean is just true or false. So if we send true, then the other node can start, and if we send false, then we can like stop the node. So this line here is just to import that functionality, that service, and that's step one complete here. So the next step is to actually implement the service client, and that's going to be in the constructor of the Python class here. So essentially, a constructor is whenever you call an instance of this class, this constructor method is always run. And to make this class a service client, we need to implement some code in the constructor. So that's what we're going to do next. And that code is going to be this right here.
Wait, Rahul, so I saw someone just joined. Would you mind like showing that main architecture slide and just giving a quick catch-up summary?
Yeah, sure. Yeah, thanks for letting me know. All right, so let's see. So for the person that just joined, just a little bit of overview of what we're making here. So we're creating a system, a ROS architecture that's going to do the following. So we're going to have a video stream, right? So you can think of in a robot, this video stream could be generated by a camera or something like that. And essentially what we want to do is we want to convert that, it's going to be a color video. We want to convert the images from that video, the frames from the video, to grayscale for 30 seconds, right? So essentially the exercise we're doing today is how do we do that using ROS? And ROS is essentially the software that we use on all our robots to program them. And this diagram here is sort of the building blocks of how we would do that in ROS, right? So we're going to have one node, which is essentially a Python script that's going to act as sort of a timer, have some timer logic in there. And it's essentially going to start up this other node, which is going to subscribe to the video stream, convert those the video stream to Grayscale, and publish it back out where we can use it elsewhere. So that's essentially the overall project. And we just started working on the first node that I mentioned. So we just started working on this perception manager node here. And so the part that we're in is we're essentially like making this node a service client so that we can start up another node. And the line that I just put here is ROS1 wait for service perception service. So what this line does is it essentially it connects it to the other node, right, that we want to communicate with. And the service that's going to be in the other node, we're going to name it perception service. This is going to be the name of the service that we want to be a client for. So that's the first line. And then this next part is a kind of wordy to type out, so I'll just copy and paste it here. So these next few lines here, all it essentially does is it finishes connecting to the server. So it tries to connect to the other node, the server, and if it can connect to it, then it sets the service to a variable that we can use later whenever we want to like start up or stop the grayscale. But if there is some communication issues, then it'll just display this message here. Okay, so we finished setting this node up as a client so that we can essentially communicate with another node to actually convert the images. And yeah, guys, just chime in with questions. Like if there's anything confusing, like don't be shy to do that. All right.
So the client and service, they're both nodes themselves.
So the node is perception manager. Like this is what we created. And we're essentially, this code right here, it turns the node into a client. So like, sort of like if we're adding or maybe that's not a good way to put it. We're adding a client to this node. It's kind of like when we do like a publisher and subscriber. If we add a publisher, we're like adding a publisher to the node. You know what I mean?
It's like an object inside of your node. Is the client like an object inside?
Yeah.
Or is the node an object?
Well, I would say the client is more of like an abstract thing. So this node is a client, right? Because we're going to be communicating with a server. We're going to be sending a request to a server. So the object inside is actually this line 27 right here. It's going to be the service that we use to send a request. But because we're in this node, we're sending a request and we're not receiving a request, that makes the node the client. Does that make a little bit of sense?
I think so, yeah.
Okay. All right. So that's to-do list number 2, implement the service client. And so we did that. And then we're going to need to implement the start and stop perception methods. And the reason that we need a start perception method, I called it start grayscale and stop grayscale here, is because remember in the exercise, the task was to only do this for 30 seconds, right? And the video is like 10 minutes long. So we're going to need to start it up at the beginning, and we're going to need to stop it 30 seconds later. And the way that we're going to do that is we're going to be using the service that we imported, the setBool service. So this part is pretty simple. So to start the service, all we got to do is use this service object that we have here, and we're going to put true. And what this is going to do is it's going to send a service request with the true Boolean variable to the server. And in the stop grayscale method, it's basically what you would imagine. The same thing, except you just send false, right? All right, so that's it for step number 3. Implement the start and stop perception. So basically, when we call these methods, when we call these functions here, it's going to send true or false to the other node that we're going to be creating later, and that node is going to have a callback function once it receives this message here to handle that, and then convert the video to grayscale or stop converting it to grayscale. All right, so that's 1 through 3. The last thing is to implement the timer logic, right? All right, so to do that, in this case, the best place to do that is probably going to be the run method. And just a little, so what is the run method? So every ROS node is going to have a run method. And what this run method will do is it will run at a specified rate. So as you can see here, the first thing that you usually do in the run method is you define a rate. And we just defined this to be 10 Hertz, which will mean it'll run like 10 times every second. And we just have a while loop here. So while not ROS1 that is shut down. So essentially, while everything is still running, it'll do everything in this loop right here. And this rate.sleep essentially ensures that this loop is running at 10 Hertz, or whatever you specify here, no faster, no slower. Okay, so here we need to put in some timer logic to convert a video to grayscale for 30 seconds, right? Okay, so to do this, what we can do is we can create our timer variables first. And we're gonna basically, to do a timer, this is in ROS, but this is, if y'all have done timers before, or if you haven't, it's gonna be the same type of thing in anything you do. So like if you're working with like microcontrollers or different programming languages, like this is like one common way just to do like a timing stuff. So you can have one variable that's set to current time, and set it equal to ROS1.getTime, and that'll just like return the current time in the program. And you're gonna have another variable that represents the previous time. And a little trick that I like to do in Python is actually set this to infinity. And that might seem kind of weird, but I'll explain like why I do this later, or like in a second. All right, so implementing the logic here. So we're gonna do this in an if statement. So for the if part, we're gonna say if the previous time minus the current time is equal to infinity, then we're going to start the grayscale. We're going to start converting the video to grayscale. And then, after we start converting the video to grayscale, we're going to set the previous time variable equal to the current time variable. And the reason that I set the previous time to infinity at the start of the code is just to ensure that this is executed first every single time. Because like it basically ensures that if we didn't do this and we set this to like some large value, or some arbitrary value, we don't really know what this difference would be, because depending on like how fast your computer runs or whatever, then this difference could be different every time you run it. But if you set it to infinity, you know this difference is going to be infinity every time. So it basically ensures that this code will be run first every single time you run this program. So that's just like a little trick that I like to use. So for the next thing, we're going to have if the current time minus the previous time is greater than 30, then we're going to stop converting the video to grayscale, and we're going to set the previous time equal to the current time. And every time I have this line here, basically where I set the previous time to the current time, that's effectively restarting the timer, because then this difference will be equal to 0. And so that's all we really need for the timer logic. So again, just to recap this part is basically saying as soon as the code starts, start the grayscale, start converting the video to grayscale. And this part is saying, okay, after 30 seconds, stop converting to grayscale. All right, so that's actually going to be everything we need for this the perception manager node. So any questions about that? Just this node in general? Before we move on to the next one? All right, let's move on to the next node now. So before we move on, let's go back to the main architecture so that we can get back to the big picture of what we're doing. So we just created this node right here. And again, what it does, it just implements some timer logic that's going to start this other node to convert video to grayscale for 30 seconds. And now we're actually going to work on this node, which is actually going to subscribe to the video, the color video, convert it to grayscale, and publish it back out so we can view the grayscale images and do whatever we want with it. Okay. All right. So here's the sort of skeleton code for the grayscale node here, and we have a similar type of to-do list here. So the first thing we're going to do is we're going to have all our necessary imports at the top. So for this node, the necessary imports is we're going to be importing ROS1 again. And we're going to be importing the same service that we used in the client, because when we have a service, right? When we have a client and a server, we need to import the service on both of them. And again, the service that we're using is called setBool, and the setBool response. So the client is going to send the setBool message to this node, which is the server, and this is going to send back the setBool response. All right, so On this one, we're actually going to need to import a few more things. We're essentially going to import some libraries that are going to help us with converting the video to grayscale. So the first library we're going to import is called CV2. This is a library, it's called Opencv, and essentially it's a library that helps with all types of like image processing stuff, working with the images and computer vision and stuff like that. Another thing we're going to need to import is something called a CV bridge. And what this does is when we subscribe to the video stream and we get the images in from the video stream, they're not going to be in the right format for Opencv to work with. And again, Opencv is this CV2 right here. So the CV bridge will actually convert that image message to the right format, so we can work with Opencv, convert it to grayscale, and then publish it back out. And the final stuff we're going to import is the messages that we're going to be working with here. And the messages we're going to be working with are compressed images. And this is essentially the, if we go back to the architecture here, this video stream, it's going to be publishing out these compressed, or we're going to be subscribing to the video stream topic, and the messages that we're going to be receiving are those compressed images messages. So we need to import them up at the top. All right. So again, this is the same thing as the perception manager node that we already created, same type of format. We're going to have a constructor here. And the first thing we're going to do is we're going to implement the server and the callback functions. So we finished step number 1. So moving on to 2. And the way that we implement the service here is this right here. All right, so what is this this line of code exactly? So we're creating a service. We're calling it S, right? The name of the service is going to be perception service. The type of message that's passed from the client to the server is the set boolean message, set bool. And the callback function that's going to handle the request from the client is going to be called perception service callback, which I already sort of made the declaration for here. All right, so we can go ahead and fill this callback function out. So let's think about this. So when will this be called? It's going to be called when we call the start grayscale method in the previous node. When that's called, then it's going to send a set bool message that has the true value in it, and this node is going to receive it, and then we're going to go enter into this callback function. So we need some sort of variable here that's going to be sort of flipped every time the grayscale is started or stopped. And we can just we can define that variable in our constructor, and we can call that variable enabled, and we can just set it to an initial value of false, just so that it's only set to true when the other node sets it to true. So this variable right here is just going to basically let us know if it's true, we want to be converting to grayscale. If it's false, we don't want to be. So the way that we're going to implement this callback here is we're going to be setting the enabled variable in our class equal to whatever is sent by the client node. All right, so that takes care of the service side of things in here. And the step number 3 we have to do is add all of our publishers and subscribers. And before I move on to that, let me know if there's any confusion on how the communication between the two nodes is happening using the service. I know it can be a little bit confusing and stuff like that. So yeah, let me know if there's any questions there. Okay, we can move on to step 3, which is adding the necessary publishers and subscribers. Okay, so because the goal is to convert the video stream to grayscale, we're going to need to add a subscriber so we can subscribe to that video to actually get the images that we want to convert. And the way that you create a subscriber in ROS is like this. So I'm just creating a subscriber. I'm just calling it a sub video. And setting it equal to the rospy.subscriber. And the first thing that we need to put here is the topic that we want to subscribe to. And the name of the topic is this. So the topic name is going to be different depending on what application you're using. So like, for example, if we're working with the boat or the sub, and we're working with the video from the camera, it might be like a different name than this. It's kind of arbitrary depending on what is publishing the video. And the message that we're going to be receiving from this topic is a compressed image. And that's the second argument in the subscriber. And the final argument is a callback function that we have to implement. So I just named it video callback. So essentially what this means is that whenever a compressed image is received by the subscriber, then immediately this video callback function is triggered. So we need to think about, okay, so when we receive an image, when we receive a frame from that video that we're subscribed to, what do we want to do? And that stuff that we want to do, we need to code it up in this video callback function. So let's think about that here. So essentially what we want to do is we want to convert that image to grayscale, and we want to publish it back out so that we can work with that grayscale image, maybe just viewing it or doing something with it in another node or something like that. So we need to convert. Oh, I guess I already made a comment here that says what it's going to do. All right, so to publish it back out, we need something called a publisher. And we can go ahead and take that here.
Is there a reason why the service is not a class variable? Like you have a self.publisher and self.server, but the service is not.
Oh, okay. So the service is not a class variable. I think because we don't call it anywhere in this code. So in the perception manager,
Mhm.
we had the service proxy as a class variable because like we call it elsewhere, like we call it in this start grayscale and stop grayscale.
Right.
But in here we don't do that. So I think it's
Is it because you're just like initializing it, or?
yeah. So if we let's say that we wanted to call this this variable somewhere else, then we would need to have the self here. But I think that's a good point. We might not even need that there, because essentially we're just defining the service here.
And that service is what's being queried by the other file we wrote, or what you wrote.
Yeah. So the other file is sending a request to
To this service.
the service, and the service once it receives the request, the callback's going to be triggered, and then a response is going to be sent back.
Okay, I think that makes sense.
Yeah, I think it might need this variable just to initialize it. But the reason that it doesn't have the self is because it's not called anywhere else in the code.
Okay,
Yeah.
thanks.
So my bad, guys. My computer is low on battery, so I need to plug it in real quick. Guys, absolutely nothing embarrassing happened there, and we're just continuing as normal. All right, let's go. Okay, let's go screen number 1. Okay, you guys can see the code again?
Yeah, we can see. Yeah.
All right, sweet. All right, so we were in the middle of creating our publisher here. And publisher is very similar to the subscriber. The first argument is going to be the topic that we're going to publish to. And we're just going to name that grayscale out compressed. And that's just it's up to us what we want to name it. I just named that because it made sense, because it's a grayscale we're publishing out, and it's going to be a compressed image. And the message that we're going to be publishing is the same as what we're going to be taking in, a compressed image. And the final argument for a publisher is the queue size, which usually if you look at the ROS documentation, selecting the queue size is sort of a difficult thing to do. And it's recommended to use either 1 or 10, I believe, something along that order of magnitude. But I wouldn't worry too much about the queue size right now. And finally, we're going to be needing to create an object, create a variable to hold our CV bridge. So we're going to be calling a CV bridge object here. And we're going to be using this to, again, to convert the compressed image messages into a format so that we can use Opencv to work with it, to convert it to grayscale. All right. So we're done with step number 3 here, adding the necessary publishers and subscribers. And next, we're going to actually need to do the grayscale, implement the grayscale conversion. And I just created a little declaration here of a method that a function that we can use to do that. And yeah, sorry guys, I'm using the words function and method sort of interchangeably. They essentially mean the same thing. I think in Python it's more normal to call it function, so I'll try to do that. So in the convert to grayscale method, we're taking in an argument, which is the compressed image message, and we can start by converting this compressed image message into a format that Opencv can work with. So we can just call this CV image, and we can call that CV bridge that we declared in the constructor. And the CV bridge has a method called compressed, or it has a function called compressed image message to CV2. So essentially, it just takes in the compressed image message and converts it to a CV2 format so that Opencv can work with it. And after we do this, we can convert the CV image to grayscale. So we can just call this CV gray image. And using the Opencv library that we imported at the top, we can use this method called CVT color. We pass in our CV image, and this the second argument essentially is telling the method that, or telling the function that we want to convert the color image. We want to convert the color image, which is like BGR, blue, green, red, to grayscale. So after we do this, we need to convert this this Opencv image back to a ROS compressed image message so that we can publish it back out and work with it. And the way that we can just call that gray image message. And similar to the first line here, we're going to be using the CV bridge to do this. And this function here, CV2 to compress the image message, is essentially the reverse of the first one that we called. And we want this method, or we want this function to return the grayscale image message that we just converted. So that was step 4. Again, please let me know if there's any questions here. And finally, we want to implement the subscriber callback. So this callback, essentially when it receives data, when it subscribes to the video stream and it receives data, this function is going to be called. And the first thing we need to do is convert this this compressed image from the video stream to grayscale. And we do that basically using the function that we just created, the convert to grayscale function. So we can create a variable called gray message and set it equal to our return from the convert to grayscale function that we just implemented. And we're going to pass in the message from the callback, the message that we received from the topic. And once we do that, we need to publish it out to the topic that we defined up here on line 31. And the way that we do that is we call the publish method of the publisher that we defined up there. And we pass in the gray message that we want to publish. All right, so that's everything that we needed to do for this Grayscale node here. And again, we have this this run method, which is going to be in every ROS node that you create. And essentially, it's going to make sure this node is running at a rate that you desire. We're going to be using 10 hertz here. And also in every in ROS method, the way that we usually do ROS nodes, I guess in DTMR, is we create a class for the node, and in every file we have a main function that essentially calls an instance of that class and then calls the run function. And the same thing is done in the other perception manager node too. And another important thing that I forgot to mention was that in every constructor, there's just to make sure that ROS knows that this class here is a ROS node and not just like a regular Python class, is you have to call this init node in the constructor of your class. And the same thing is done here with the name of the node being Grayscale here and perception manager in the other one. Okay, so going back to the big picture, we did this. We implemented the perception manager node with the timer logic. We implemented the Grayscale node, which converts images to grayscale, and we implemented the service, which makes this perception manager the client, the Grayscale the server, and we implemented the communication between the two. And we implemented the publisher and subscriber in the Grayscale node to subscribe from the video stream and publish out the Grayscale images. So basically all of the coding is done that we need to do. The only thing that's left is we need to create a launch file so that we can actually execute these nodes here. All right. And here is the launch file. So all of this stuff at the top here that I've highlighted from line 3 to line 25, that's just a node that's publishing out the video stream so that we can actually work with it and convert it to grayscale. So let's say that we're working with like our boat or a sub or something like that. Instead of this node that we're launching here, we're going to be having like some node to stream video from our cameras or different sensors and stuff like that. All right, so we have this, and these two nodes here, or these two lines in the launch file, is how we're going to be running our nodes, right? So the first line, line 27 here, we specify the name of the node, which is the perception manager. We specify the package that it's in, and the package name here is GTMR ROS intro. And the type is essentially equal to the name of the Python file that the node is implemented in, and it's perceptionmanager.py. But I believe the one that we implemented it in is called perception manager _ skeleton. So maybe just redo that. And I believe the package is a bit different here. And again, the package is just it's basically a collection of launch files and nodes and things of that sort in ROS, just to organize code basically. All right. So this line launches the perception manager, and this line here launches the grayscale node. So the grayscale node is actually grayscale underscore skeleton. Yeah, and this final argument in this line saying output equals screen, essentially that's saying we're allowing print statements, but we're not really going to be printing anything, so we don't really need this. Yeah, and again to recap, so this launch file, so in a launch file, you put all the nodes that you want to launch, and the nodes that we want to launch is the perception manager node and the grayscale node, and in the lines where we launch the node, we specify the package and also the file name that the node is located in. All right, so we have all of the pieces in place to go ahead and to test to see if this works now. So before we do that, any questions about the launch file?
Don't forget to save your skeleton files.
Good luck, good call. All right. So, okay. So I guess we can move on to running the code here. All right. So the way that you launch, you run a launch file is using this command called ROS launch. So ROS launch, it should be my terminal is slow right now. ROS launch. Okay, so sometimes what you have to do if the command won't work is you have to run this source command here. And essentially when you make a lot of changes and sometimes when you exit your terminal and come back, you have to run this just to get all of the packages in memory and stuff like that. So ROS launch, our package name, which is gtmr ROS intro, and our launch file is called tutorial skeleton.launch. And let's see what's going on. Looks like there is an error here. Oh, okay. So it looks like in the launch file, I had the wrong package name of where to find the video to stream. So we can fix that. Try again. All right. So it looks like it's running here. And yeah, here's the video that's streaming. And a video, another command that we can use to view the grayscale video is called Rqt Image View. So ROS run Rqt Image View, Rqt Image View. So that's going to allow us to see our grayscale video here. And you can see that the video is streaming out, but it should stop soon because remember, we're only running this for 30 seconds, right? So if everything is correctly coded up, then within a few seconds, the grayscale video should stop and the color video should continue streaming. All right, so I know it's getting kind of a little bit late. Um, but I guess for this reason, kind of, I coded this up like over the weekend. So I do have like a backup code that works. So whatever is going wrong in this code, it might take us a while to like debug that. So I think what I can do here is I can just run the backup code so y'all can like see how the final product looks like. Would y'all be cool with that?
Go for it.
All right. All right. So in about 20 seconds, should be stopped. There you go. So as you can see, the left image stream, the video stream, is still running, but the right one has been stopped by the service. And it's also printing out on the terminal here. You can see that the enabled variable is set to false, which causes this to stop. Yeah. So that's how the code performs, using the two nodes that we created and the service to communicate between them, and also using the publishers and subscribers to subscribe to the video feed and output the grayscale video. Yeah, I don't know. It's probably some weird little something that I forgot to put in this new code, or some little typo somewhere that caused it not to work in the new one. But you guys can see what the finished product looks like.